Hello everyone, welcome back to this channel. So in today's video, I want to announce that I'll be starting a new video series on IGCSE physics. So there will be 25 videos coming up, including this one, that will help you to understand the whole syllabus from A to Z. So without further ado, let's dive into chapter 1, making measurement. And in this chapter alone, we'll learn how to measure 4 different quantities: length, volume, time, and also density. And they might sound really trivial. So let me explain what are the reasons that we learn this. So one example I can think of why measurement is important in this Mars Climate Orbiter incident. So what NASA did is that they sent out this orbiter to basically orbit the Mars to study the properties of Mars. And unfortunately, they make a measurement error, and specifically they uses the wrong unit for part of the measurement. So they use pounds for seconds instead of Newton seconds. We'll talk more about what they are later. But because of this minor error, the mission end up to fail, and it causes millions of dollars for this failed projects, and the cause is just a measurement mistake. So now I hope that this example gives you some motivation to keep learning in the following slides. So let's look into how we can measure length properly. So, and the lab lengths are often using a ruler. In fact, we use ruler every day in our daily life, but it's important on how we make use of the ruler better. And here are some of the examples of what we need to measure. And some of it would be a piece of wire. Let's say you're doing an electricity experiment to investigate how length of wire affects resistance. So we might need to measure the length of wire. And here are some of the precautions. First of all, your wire must be straight, and the wire must start at the 0 point, so they got the exact figure. And last but not least, the ruler have to be calibrated. Calibrated well means that from 0 to 1, it is exactly 1 cm instead of 0.8, and that would ended up causing a huge mess. A little error would cause a bigger error in the actual experiment. So that's one example. And a second example where we need to measure is the thickness of something. For instance, here we have paper. It's not easy to measure just the thickness of one paper. Here's an example of how to do that. We stacked up all the papers, like 500, and then measure the thickness of the 500 pieces of paper using a ruler. And to get the thickness of one paper, we simply divide it by 500 to get the thickness of one sheet. And another example would be a thread. All right, how do we measure a thread? So it's very much like how we measure a wire. You need to lay a thread on the line and then put the line on the ruler to get the exact measurement on how long is the thread. So here are just 3 examples of how you can measure the length. And here I want to introduce another concept, which is super important throughout the course. It's called the SI unit. So SI unit is basically a standardized unit that is used throughout the world. It means that these units are the standard for scientists all around the world. So for length, the SI unit is going to be an cm, all right, or meter sometime. It should be meter. The SI unit is meter. And of course, we can change it by using different prefixes. Oops, like centi, deci, milli, micro, kilo. So do know that this M here, it is the SI unit when it comes to a lot of measurement question you need to do in the future. And this is important because imagine that you're staying in England, they might be using a mile system instead of a kilometer system. So there's a big difference between kilometers and miles, and therefore it's good for scientists to have a standardized unit. In this case, the SI unit. All right, so let's try out some puzzle questions. In fact, throughout the whole syllabus, you'll do a lot of puzzle questions just to prepare you to ace your exam. So here, this student wants to determine the circumference of a wooden dowel. She puts a mark on the dowel, this mark here, and then rolls it along the ruler 3 times before the reading the position on the ruler at which it stopped. So to solve this problem, we need to understand the context. So this roller here is spin 3 times. And we know that after it spins 1 time, it should be the circumference. We should be able to get the circumference of the circle. So let's look at what is the length, the starting point on the mark. So this is the starting point, which is 1 cm. So do note that the scale here is from 0 to 5. So each bar here represents 1 cm. And it started at 1 cm, and after one cycle, we look at whether when it stops at 13 cm. So this means that the whole circumference of the circle has traveled one cycle. And in order to get the circumference, we simply use 13. Let me use another pen, the ball pen instead. 13 cm minus 1 cm, we got 12 cm. And this will be the circumference of the diver. So the answer is A. And let's move on. Yeah, the answer is A. So the second thing that we'll measure in this chapter is volume. Some of you might have already done it in your mathematics subject. So here we have some regular shapes here. We know that to calculate the volume of a cubic, we multiply the length times width times height. Whereas for the volume of sphere, you might remember this formula for over 3 pi r cubed. And for cone, if I'm not mistaken, should be 1 over 3 pi r square h. And we have different formulas to calculate the volume of regular shapes. But one thing that some of you might not know is how to calculate the volume of an irregular shapes, like this, like a stone here. And the way we do that in physics is to use a method called the water displacement method, where we prepared a measuring cylinder, we put in some water, and then measure the initial volume of it. And because the rock has volume, therefore when we put the rock into the measuring cylinder, we'll see an increase in the volume of water inside the measuring cylinder. So in order to calculate the volume of the rock, we simply use the final volume and subtract it by the initial volume. And this will give us the volume of the rock. And this is called water displacement method. And here we have a new equipment that you need to know is basically called measuring cylinders. They are used in water displacement method. Basically, a cylinders that has measurement beside of it. All right, and the SI unit again. For different unit, we have different SI unit, and the SI unit for volume is meter cube. But of course, you can always add prefixes to make it cm cube or dm cube. So here should be deci. All right, by the way, if you're interested in getting the slides here, you can always download it on my website for free for chapter 1. But if you are a teacher or student would like to use these slides for revision purposes, then you can purchase them on my personal website. And thank you for supporting. And let's move on to how we can measure time. And measuring time is super simple. And sometimes we need to measure time because throughout your journey, you'll be required to do some experiments on, for instance, how long does it take for water to heat up and comparing different liquids, and also how long an electric current is flowing. So to measure time, we use clock, and we have two simple clocks here, analog clocks and also digital clocks. Something that's very common sense, whereas digital clock here is more accurate because they sometimes have additional time like milliseconds, nanoseconds, and so on and so forth. And another way, a traditional way of measuring time is using a lap pendulum. And you might thought, why would we need this thing, right? This is because sometimes, what if you don't have a clock in your hand and you can create a timing device using this lap pendulum. And it works because it oscillates at a very constant period. And the time for one oscillation moving from left to right, right to left is called a period. And because the pendulum swings at a steady rate, they are used sometimes to conduct experiments. And in order to calculate how long it takes to oscillate, we can use a stopwatch. And of course, when we measure that, we need to do many oscillations so that the timing error, the reflection error, will be lower. That means the time for human to react when they press the start and stop button in their stopwatch. So this is lap pendulum, and of course we can change how long each oscillation is by changing the length of the wire here. All right. So let's move on. So here's another puzzle question. A student is trying to see how quick they can run. One way I would recommend all of you to answer puzzle question is to underline the key term here. You cannot use highlighter, but you can underline the keyword. And let's read. The reason that if they know how fast they can run one lap, they can assume they will run at the same speed for 5 kilometers, which is extremely hard, but that's the question, and can calculate their predicted time. They correctly reason that they will not be able to maintain the initial pace throughout the whole 5 km, so they decide to time lap 5. The diagram shows the reading on the stopwatch at the beginning and the end of the lap. So how long does it take? So remember that they are running for one lap. So this is only one lap. And the amount of time we need to measure in order to order how much they can travel in 5 kilometers, we need to first measure how much they can run in 400 meter. So in this case, the end of lap is 11:10. The start of lap is 9:13. So we can use the subtraction here. But of course, in this case, we know that 1 minute is equivalent to 60 seconds. So I'm going to change it to 10 and 70 so that I can subtract it. So I have 55 seconds and 1 minute and 55 seconds for 400 meter. All right. So in order to calculate how much they travel in 5 kilometers, we can use, so we know that they travel 400 meter and for 1 minute and 55 seconds. And for 5 kilometers, how will they travel? And we know that 400 kilometers, if you multiply by, and let's use the calculator because I can't do it that quick. Oops, 5,000 is 12.5 times. So 5 kilometers is 12.5 times 400 meter. So we can do the same to our time here. So we can first convert this into second and then multiply 117 multiplied by 12.5. We know that they will spend 1,462.5 seconds to run the whole 5 km, but we do need to convert it into minutes. It will be 24 minutes and 22 seconds. So I know the calculation part is a little bit hard. So if it's okay if you don't get it, you can pause the video and try to solve it yourself. But that's basically how the question on your exam will be like. They're usually complicated and requires a lot more time to solve. So that's measuring time, and then question here, we know that the answer is B. And let's move on to density, and some of you might have learned it in year 9 math. So far we have learned how to measure length and also measure volume. So density is basically how concentrated a matter, an object mass is. So we can, here is a visualization. A dense object would have a lot of matter concentrated in a small volume, whereas a less dense object here will have less matter concentrated in the same amount of volume here. Okay, and the formula to calculate density is to use mass divided by its volume. And let's look at some of the units for density. If let's say the mass that you are using is gram and volume is cm cube, your unit of density is gram divided by cm cube. So it should be a slash here. And then if your unit is kg and cm cube, you get kg slash cm cube, so on and so forth. All right. And the implication of density, this one should be quite simple. If an object is denser than water, it will sink, whereas if it's less dense than water, it will float instead. So let's look at some of the work example to help you understand how to solve it. So a sample ethanol has a volume, remember, to which underlined the key term, and the mass is 190 gram. What is the density? And because we know that the mass is 190, we can just plug that in value into our equation. 190 divided by the volume, 240. And because the volume here, the mass here is of has the unit gram, I can just write it down here for my visualization, and cm cube. And if I plug this value into the calculator, 190 divided by 240, I'll get 0.79. A recommended way to write your answers, you will get a lot of continuing numbers here, but then it's good to always write in 3 significant figures. So I'm going to write 0.792, and I just plug in the unit gram because cm here is at the bottom, at the denominator. So this is why I will put a slash here and then write out a unit. And that's how you construct a unit for a term. Basically, you don't have to memorize too much. Just remember the formula and it would do. So let's move on. And a box full of 35 matches has a mass of 6.77 gram. The box itself has a mass of 3.77 gram. What is the mass of 1 match in grams? So this is a math question, right? So basically, the total is 6.77 gram, and then the box is 3.37 gram. So we know that the mass for the 35 matches will be 6.77 minus 3.37, which is 3.4 kilogram. And in order to find the mass of one match, you can just do one match. You can basically divide 3.4 by 35. And the answer you get is 0. Remember, 3 significant figure, 0.097. What about unit? It's the same as the gram here. So I'm going to put 0.097 gram. And let's move on. A box, now we need to calculate the volume in cm cube. So here's a specific requirement here that we need to give our answer in this unit. But then if you look at the dimension, they give us 42 meter, 2.3 millimeter, 2.3 millimeter, the width, length, and height. And this is when something becomes trickier because the answer requires us to write in cm cube, meaning we need to convert millimeter, the dimension, to centimeter before we do any calculation. So I'm going to convert 42 to 4.2 cm. 2.3 mm is equal to 0.23 cm. And I can then calculate the volume by multiplying them together. 4.2 cm multiplied by 0.23 multiplied by 0.23. And if I plug all the values into the calculator, I will get the answer of 0.222, and the unit cm cube. And here there is it. We have the volume of the matrix. So last but not least, we need to calculate the density of one matrix. So to calculate the density, we need the mass and also the volume. So from the previous two example, the mass of the match is 0.097, and then the volume of it is 0.222. So again, I just plug the values into the formulas and then use my calculator to calculate what is the density of my match. So then here we have 0.437 gram slash cm cube. Remember to use the unit that the mass and to follow the unit of mass and volumes. So here we have another way to find the density of liquid. So this is for liquid specifically. Again, we remember that formula for density is mass divided by volume. To calculate the density of liquid, we just have to measure the mass of liquid and also measuring the volume of liquid. And one simple way to do this is to put a measuring cylinder on a beam balance and then measure the initial mass and then pour in the water. So we can see that here that the changes is 70 minus 50. So we know that the volume of the water is 20 maybe cm cube. All right, 20 cm cube. And then, sorry, the mass of the water, sorry, I made a mistake. So the mass of the water is 70 gram minus 50 gram. Got 20 gram here. And here we have the mass already. And then to measure the volume, we can just look up the reading here, volume. And after getting the mass and volume, we just plug it into the formula, and then we'll have gotten the density. So that's about it on how to calculate the density of liquid. And before we end this video, let's try out a few more passive questions. So how can the student, it's a 4-mark question, measure the volume of one of the coins using the setup? And I have attached the marking scheme here, you can refer to it. But a very simple thing to do is first to fill up the water, fill water into this measuring cylinders, and then we can put all the coins in. Of course, before we put in all the coins, we need to measure the initial volume. And having put all the coins into the measuring cylinders, we can measure the final volume. So in order to calculate what is the volume of one coin, we can just use final minus initial and then divided by the number of coins that we put into the measuring cylinders. So that's one way we can all answer the question. Remember always, if it's a 4-point question in your IG exam, meaning you are likely needed to give 4 additional points. So try not to be too lengthy, but give the correct points in your exam. And last question, 3 blocks are put into 3 measuring cylinders, and these are shown below. So which rows in the table shows the block in order of increasing volume? So we can just see that we can just check which measuring cylinders has the lowest increase in volume. Then we know that this the blocks have the lowest volume, because this is essentially a water displacement method. So I can see that Zach here has the lowest increase in volume, so that should be the smallest. And the second increase in volume should be here, X. They only increased by 30, whereas the first one, it increased by around 30, sorry, 27. If we look at the reading here, they started at 43, they ended at 70, so it'd be 37. Whereas the last one, they started at 25 and it ended at 85, so increased around 60. So we know that the order is Z, X, and also Y. So the answer is donkey. So here it is, we have our final answers. So to sum up this chapter, we have learned how to measure volume, length, density properly. So in the next chapter, we'll learn how the different formulas and also about speed and accelerations. I'll see you then. Goodbye.